type is void. And we'll see this again and again in more clarity. Yeah? Oh, so there is. We just scrolled beyond it. So if I scroll back up, recall that we began the story with main just as usual. Yeah?
If you declare a variable in main, will it still be declared in another function of the main?
Really good question. If you declare a variable in main, will it be accessible to another function like chorus? What do you think? So no, and again, you can fall back on the same rule of thumb. Variables only exist within the confines of the curly braces. So main has its own curly braces at the very start and the very end. So any variables in there are not, in fact, accessible by a function like chorus. And let me point out one other detail here before we can put to rest this singing song example. There's one piece of new stuff at the top of this file. So besides all of the comments up at the top of the file, besides my use of include cs50.h and standardio.h, there's this thing whose word is going to be called generally a function prototype. Well, what does this mean? So C is kind of stupid, right? It's an older language. The compilers for it are fairly, even though they've been updated over the years, they were very simplistic in terms of their design early on. And what does that mean? It means that the compiler, if you don't tell it in advance that a function exists, like chorus, and it encounters that word somewhere in the program before it's actually seen your implementation of that function, it's going to yell at you. It's going to trigger some kind of error. In other words, let me do this. I'm going to undo all of the changes I've done in this example, just so we know I didn't screw it up, and it's back in its pristine form. And we'll come back another time to this syntax of doing the minus minus inside of the parentheses there. I'm going to go up to the top here. I'm going to expand my terminal window. And I'm going to go ahead and compile this thing, which again was beer4. So make beer4. I'm going to go ahead and run beer4, and I'll type in, just 2 bottles to keep it short and simple. That seems to work. No weird side effects. So now let me break it. Let me accidentally delete this thing that we're calling a function prototype and just start typing main. And now notice if I scroll down further, main's there. And chorus is still there. So in theory, I have all the building blocks I need. I've dragged all of my puzzle pieces to the stage. But again, C is not quite as smart as Scratch. C cares about the order in which you do things. So if I now recompile this thing with make beer4, enter, a whole lot of stuff just broke. And this is the most telling line. And you might have seen this yourself over time. Implicit declaration of function, in this case chorus. Has anyone seen a similarly sounding message? Do you remember what the solution was the past week? Include the header file, right? If you've ever seen this message thus far, or you see this message in the future, implicit declaration of function just means you used a function, in this case chorus, but you didn't tell the compiler what it looks like, what's its return value, so to speak, and what's its input, what's its output and what's its input. And you kind of did, but you told the compiler it too late. You put your function all the way at the bottom of the file. So as soon as the compiler started reading your program top to bottom, left to right, it encountered this special new word, chorus, but you've never told it that there's a chorus function in existence before, so it throws this error. So just think intuitively, what's the quickest fix for this, perhaps? And the answer is not function prototype. Yeah? That sounds perfectly reasonable, right? So if the problem is I'm declaring chorus too late, I'm teaching the compiler about it too late because I'm using it in main, all right, well, let's just relocate it to the top of my file. So now chorus is at the top, main is at the bottom. Let me go ahead and zoom in now, and let's redo this. Make beer4. Well, that actually did fix it. So that is indeed a very reasonable solution, but it's probably not the best because you can definitely, once your programs get more complex, you can definitely come up with scenarios where X has to call Y, but Y might call X. So you might get into these possibly these circular relationships where it's just impossible to put one above the other logically. And also, it's kind of nice as a matter of good style to just always put main at the very top of your program, because if you open a program that you wrote or someone else wrote for the very first time, You don't care about a function called chorus or anything else. You want to see what does this program do, and the answer to that is almost always going to lie in main. So ideally, we want to leave chorus where it was, below main, but it turns out the simple solution then is just to tell the compiler about this function before you actually implement it, and you just can do this with a one-liner. You specify what's its output, in this case void, what's its name, chorus, what's its input, int b. So in other words, you literally copy and paste the first line or two of your function and just put a semicolon at the end. You don't do open curly brace. You don't start writing your function. You just do this one-liner. And notice that is now identical to what's down here. Now, why this? This is just a matter of convention. It is perfectly legitimate to write your functions all on one line like this. But if you look back at the CS50 style guide, you'll see that we discuss why this is actually useful. Long story short, if you're using a text editor or like some kind of programming tool and you want to search where in your file you've actually implemented a function like chorus, there are usually little tricks in the find dialog to say start searching at the front of a line, the start of a line. So the fact that if you adopt this convention of putting the function name all the way to the left, it just means you can find it more easily when your files get big. But it's just a convenience, nothing more than that. All right, so we'll come back to some of these syntactic features. But any questions on the concept of writing your own function and this notion of declaring it with this so-called prototype? Yeah? Good question. Why do you have to tell the compiler that it does or doesn't have an output? Can't you infer that from the code? You could infer it some of the time. But the problem is that if you just analyze a function that you've written, you could have an if condition, an else if, and it could actually return different things, maybe not even at all. And so the idea of proactively telling the compiler, this will no matter what return this data type, is a commitment you then make to adhering to certain conventions. So in short, it improves the probability of correctness, among other things. Any other questions? All right, so let's try to generalize this a little bit. So we just wrote a function. Functions have return values. Return values are just the buzzword for output. But we can run into problems with this, again related to scope. Let's actually see a more concrete example where scope kind of breaks things for us with regard to these things called local variables. So this is a buggy program. This is buggy 3, and this is among the source code here. In lectures 2 source. If I open up buggy 3, we'll see an attempt to actually swap two variables. So let's ignore the top of the file. Let's just look at main, as is generally most useful. It looks like main declares an int called x, assigns it 1. Another int called y assigns it 2. And then it prints out their values. It then says then says swapping, ... Then it calls a function called swap, who takes 2 arguments. So it's a little different syntactically, but you just separate the arguments with commas. Then it claims on the screen to say swapped, ! And then it reprints x and y. So this program's pretty simple, at least in terms of what we've learned thus far. The only new thing is this use of apparently a function called swap, which is not built in. I wrote it elsewhere in the program. So let's see if it works. It's not going to. So let's go into lectures to source. I'm going to go ahead and compile now, make buggy 3, enter. So it compiles OK, so that's promising. Now buggy 3, enter. X is 1, y is 2. Swapping, swapped. X is 1, y is 2. Feels like this is definitely broken. So let's see. Maybe I did something stupid like I left out the prototype. Well, no. So that's there. I did include the prototype. And I should know that I did this correctly because GCC did not yell at me with implicit declaration of functions. So syntactically, this program's right. Apparently, swap returns nothing. But it takes an int, takes another int, and calls them a and b respectively. So let's now scroll down and see how I implemented this. Well, it's apparently just 3 lines of code. So swap has no output. It takes 2 inputs, a and b. Each of them is an int. And now conceptually, does this sound correct? So it actually is. So here's one gotcha first. If you've got a value, let's call it a, and another value, call it b, how do you swap them? Well, if you think about it, you sort of visually, you do this, right? But you can't quite do that in a computer because if you say a gets b and then b gets a, well, what value is in both a and b? So it's b, right? Order of operations, if on the first line you put the value of b in a, and then you put the value of a in b, well, that means that b's value, whatever it is now in both of those variables. So what's the solution? Well, you introduce, we'll call a temporary variable. Now, usually TMP would be a silly name for a variable, but if it is a temporary variable, it's quite reasonable here. So the solution is to remember what a is by storing its value in an int, then updating the value of a and putting in it the value of b. And now at this point in the story, what value is in a? Well, the value of b. What value is in temp? The original value of a. And so now we can put inside of b temp, which is equivalent to a. So we just need a third line of code. Now, as an aside, especially for those of you interested in hacker editions, there actually is a way in C code to do this, where you swap two variables simultaneously without using any temporary storage space. It's kind of a nice magician's trick, but more on that perhaps next week. But for now, this code feels correct, right? I've got a and b. I put a in a temporary variable. I change b. I put b in a, and then I put this guy here. Right, so that logically feels correct. And in fact, at the very last line here, where my cursor currently is, a and b have, yes, been swapped. But we just saw when I run this program that x and y are not swapped, even though I'm passing x and y to this function. So where do things break? Someone, yeah, in back. Oh, sure, you.
Well, it's not assigning it back outside the function.
OK. So it's not assigning the answers back out of the function somehow. OK, so that's true. And what other point can be made too? Here, yeah.
The values of x and y that it's taking from the main function get messed up when they're passing on to the swap function.
OK, so maybe the values x and y are getting messed up in some way when being passed in. So messed up isn't quite what I'd say, but there is another, there's a verb here that would apply. They're being copied into the swap function. So recall earlier, and I said it briefly in our previous beer example, that when you call a function and you just specify the input with a variable name, you get the value, but you get a copy of that value. So at this moment in time, when this program is executing, there are now 4 variables, actually 5 variables in existence in this program right now. There's x and y, and those live inside of main. There's also a and b, and also temp, TMP, so 5 separate integers. That's 5 separate chunks of 32 bits somewhere in the computer's memory. And inside of x is the number 1, apparently, if you think back to how we started. So inside of x is the number 1. Inside of what other variable is also apparently the number 1? Initially, before swap executes. So also the number 1. Y has the value 2. As soon as we call swap, B has the value 2. But then when you finish executing swap, before it actually finishes, so if we get conceptually right to where my cursor is here before it's all done, x is 1, y is 2, a is 2, and b is 1. The problem is that the goal is to swap x and y, and all we've done is swap a and b. So it seems to be a fundamental problem that when you pass inputs to a function, you're actually passing copies of them in. And the buzzword here is you're passing them by value. Now, those of you with prior programming backgrounds know that in Java, you actually don't run into this, at least if you're using objects. And we can fix this in C. Fast forwarding to a couple weeks from now, we'll introduce the notion of pointers and low-level memory addresses. But for now, let's just assume we've run up against a wall. Right now, when you have what are called local variables, which x and y are, anytime you have a variable inside of a function, it's called a local variable. It's kind of for self-explanatory reasons. It's local to that function. That function cannot, that variable cannot be accessed in some other function because a and b, meanwhile, we keep calling them arguments or parameters, but they're also just local variables. They exist only inside of swap. So at this point, then, there's 2 variables in main, there's 3 in swap, and those guys, even though they might share some values, they're copies of those values. And we can actually see this as follows.